So in this video, I'm going to work through the complex derivative worksheet, complex derivative practice worksheet. So here we go. So find the derivative of each function, simplify your final answer. In some cases, it may be useful to simplify, rewrite the function before differentiating. Like, for example, this first one. The first thing I would do is rewrite this as 4 times sine of x minus, no, I wouldn't. I'd do 1/4 times sine of x minus 3 to the negative 1 power. So this is going to be several iterations of the chain rule, driven mostly by the power rule. So the first thing we do here is the 1/4 times something to the negative 1 power. So the derivative of that, if we go dy dx here, the derivative of that would be negative 1/4 times the something to the negative 2 power. So that's the first layer of the chain rule. Then we take the derivative of the next function, next innermost function, which is sine of something. So the derivative of sine of something is cosine of that same something. And then we take the derivative of the inside of that, which is x minus 3. Derivative of x minus 3 is just 1. Okay, so then we can nothing really do to simplify that. I can get rid of that parenthesis there. Moving right along. Okay, this is looks like just a chain rule, power rule, chain rule. So the first derivative, the outer layer is something to the negative 8 power. So dy dx here would be negative 8 times the same something to the negative 9th power. And then we take the derivative of the inside. Well, the derivative of 4t minus 3 is just 4. Of course, we could simplify that by multiplying the 4 by the negative 8, and that'd be negative 32 times 4t minus 3 to the negative 9. Moving right along here. The derivative of this would be, probably want to write that as theta is equal to 2 times tangent, and then inside the tangent we have a theta to the 1/3 power. That's what cube root, that's the way we write cube root. So then the derivative of that with respect to theta, whoops, sorry, that should have been a plus there. So the derivative of theta is just 1 plus the derivative of 2 tan of something would be 2 secant squared of the same something times the derivative of something. Well, the derivative of something would just be 1/3 theta to the negative 2/3 power. So we could simplify this a little bit. The 1 plus, bring the 1/3 times 2, that'd be 2/3 times theta to the negative. So we could throw the negative on the bottom. So let's do this. Let's do 2 secant squared of theta to the 1/3 power over 3 times theta to the 2/3 power. Okay, we just put it on the bottom because of the negative exponent there. Okay, moving right along, I'll probably rewrite this first as 2z minus 1 to the 1/3 power. 1/3 power. Man. 1/3 power. There we go. So the derivative, first, the outer layer would be something to the 1/3 power. So that would be 1/3 times 2z minus 1 to the negative 2/3 power. Then multiply that by the derivative of 2z minus 1, and that would just be 2. So we rewrite that as 2 on top, and 3 times 2z minus 1 to the 2/3 power on the bottom. Here's another chain rule. Okay, now this one's interesting because it has a power rule on the outside, but then when you go to take the derivative of the inside, you have to use the product rule. So I might put a little uv there to remind myself. And the derivative of u is 4, and the derivative of v is negative sine alpha times 1. Okay, so first of all, when I take the derivative, I better do an alpha there. derivative of h. So the first part of the derivative would be outside, so that would just be something squared. So that'd be 2 times the same something to the first power. Then I got to take the derivative of the inside. Well, the derivative of the inside is going to be the product rule. So that would be the derivative of the first, which is 4, times the second, which is cosine alpha, plus 4 alpha, the first, times the derivative of the second, which would be negative sine alpha. So I'm going to just put a sine alpha there and turn that into a negative. And then we could probably distribute that 2 out. So that would be what? That would be 2 times 4 is 8. 8 times 4 is 32 alpha cosine squared minus, and that would also be 2 times 4 times 4. So that would be 32 alpha times cosine alpha sine alpha. Oh, whoops, that one already had an alpha there, so that'd be alpha squared, wouldn't it? There we go. Okay, this one's another nice chain rule. So the derivative of the outside, of course, is just going to be 3 times the something to the second power times the derivative of the inside. Of course, the inside would be what? 12x squared minus 10x plus 10, and derivative of 13 is 0. So we could distribute that 3 through, so that would be what? 36x squared minus 30x plus 30 times this whole thing to the second power. Because we have a second power there, I've given you permission not to simplify that any further. Here's a nice product rule with a couple iterations of the chain rule thrown in. So the first thing I would do is, no, I don't think I would. So I would define this as my u and this is my v, because that's the product rule I'm going to have to do. And u prime is going to be, let's see, 3 times 3 is 9 times 2e to the 5x to the second power times the derivative of the inside, which would be 2e to the 5x times the derivative of 5x, which would be 5. So that whole thing can simplify to 2 times 5 is 10. 10 times 9 is 90. And that would be, you know what, I think I'm going to do this differently. I think what I would do, because I'm going to do it in the end anyway, I think I would define my u to be, and apply that 3 to both powers, so that would be 3 times 8, because 2 cubed is 8, times e to the 15x. And of course that's going to be 24 times e to the 15x. So I think that's what I would do first, just to clean up that u. So then when I take u prime, I would get 24 e to the 15x times 15, which would be 240, 120, that'd be 360, yeah. So that would be 360 e to the 15x. Okay, and then v prime, that's just going to be 4 times x minus 1 to the third times the derivative of x minus 1, which is just 1. Okay, so now that I got those lined up, I'm going to go ahead and take the derivative over here, and I use the product rule. So the product rule is going to be, u prime v plus v prime u. And so now that I've did this over here, I can just grab the u prime. It's already simplified for me, so that would be 360 e to the 15x times v. which is x minus 1 to the fourth, plus v prime, which is 4 times x minus 1 to the third, times u. And I'll use this simplified u up here. That would be 24e to the 15x. And now there's not a lot of simplifying to do. I would, I guess I can just multiply the 4 by 24. I think that's all I'd do. 360e to the 15. Oh, did I leave off an x there? Whoops, that's 15x. Times x minus 1 to the fourth plus 4 times 24 would be 96. So that'd be 96e to the 15x times x minus 1 to the third. Now you could factor out an e to the 15x, but it's not really going to do you much. You could factor out an e to the 15x and an x minus 1 to the third power. I guess that would leave something nice inside, but I don't think it's making a big difference, so I would probably just leave it like that. Okay, moving right along. Number 8, that's a nice quotient rule. So once again, I'd call this my u and this my v. So u prime is going to be 2 times t minus 3 to the first, which would actually be 2t minus 6. And v prime, or v, is going to be t plus 1 to the 1/2. So v prime is going to be, whoops, it's going to be 1/2 times t plus 1 to the negative 1/2. Okay, so let's do the derivative, g, and we want low d high minus high d low all over low squared. And since we have all those players laid out already, we can do that. So v would be t plus 1 to the 1/2 times u prime, which is 2t minus 6, minus u, which is t minus 3 squared, times v prime, which is 1/2 times t plus 1 to the negative 1/2. And all that's over v squared. Now, t plus 1 to the squared would just be t plus 1. So that's kind of fun. Okay, to simplify this, I would probably probably multiply top and bottom by t plus 1 to the 1/2. So that would cancel those out, and that would turn that into a t plus 1 times 2t minus 6 minus t minus 3 squared, and the 1/2, the 2 would just come out of the bottom. And then I'd have t plus 1 to the 3/2 over here. And then I'd probably finish this by multiplying these out. So that'd be t times 2t, that'd be 2t squared. And t times negative 6 would be negative 6t. 1 times 2t would be positive 2t. And 1 times negative 6 would be negative 6. And then the same thing here. T squared would be, or t times t would be t squared. And there's a negative out front, so that'd be negative t squared. And then t times negative 3 and negative 3 times t, that'd be negative 6t. And that negative would make it positive 6t. And then negative 3 times negative 3 is 9, but that would make it negative, so that'd be negative 9. All over 2 times t plus 1 to the 3/2. And then I think we can go one more step here. Get everything together. 2t minus t, 2t squared minus t squared would be just t squared. And negative 6t and 2t, that'd be negative 4t. Plus 6t, that'd be positive 2t. And then negative 6 and negative 9 would be negative 15. All over 2 times t plus 1 to the 3/2. All right. We got one more here. This is a quotient rule inside of a power rule. So let's just do it from begin with. Dy dx, the outside's just something to the third power, so that'd be 3 times the something to the second power. Of course, the something is this. But then we'd have to take the derivative of the inside. The inside is going to be a quotient rule. So low would be 3 minus x. D high, that would be natural log of 4. And I made that way too small. Times 4 to the 2x minus 1 times the derivative of 2x minus 1, which would be times 2. All that minus high 4 to the 2x minus 1. 4 to the 2x minus 1. Times d low. Of course, the derivative of low is just negative 1, so I'd make that a positive. And then 3 minus x squared. So if we consolidate all this stuff, let's see. Well, I got 3 minus x squared here, or here, and 3 minus x squared there. So on the bottom, I'm going to have 3 minus x to the 4th. So that's fun. And then let's see if we can clean up the inside here a little bit. Looks like we have a couple factors of 4 to the 2x minus 1. So we'll bring these guys out too. So actually I have 4 to the 2x minus 1 to the third power, because I factored this guy and this guy out, right? And we'll leave the 3 there for a second. So then what's left on the inside here? We have a 3 minus x times the natural log of 4 times 2 plus 1. So let's clean that up a little bit. So on the bottom, that's just going to be 3 minus x to the 4th. That'll stay like that. And then on the inside, I could distribute that 3 through. So up front, I'm going to have this bit right here will, the 4 to the 2x minus 1 to the third power will turn into 4 to the 6x minus 3. So that's my outside piece. Then I'll distribute that 3. So in here, I'm going to have, let's see, 6 ln 4 times 3 would actually be 18 ln 4. So that's the 3 times that, and times that. And then we're also going to have a minus 6 ln 4x. And then finally, 3 times the plus 1 would be plus 3 out there. And that's about as clean as we can get it. And that is the complex derivatives worksheet.